Hi, this is Alex from devstories.eu. Pydantic, Data Validation, Episode 3 of 20. Standard type hints tell you a field is an integer, but they cannot tell you it has to be greater than 0. When a negative age or a 10,000 character username slips past your application boundaries, basic type checking is no longer enough to protect your backend. To enforce strict boundaries on your data, you need field constraints and the annotated pattern. In Pydantic, constraints allow you to restrict the allowed values for a specific type. Instead of writing custom validator functions for every minor rule, you can define mathematical or structural boundaries directly on the field. For numeric types, you can enforce greater than or less than bounds using parameters like GT and LT. For strings, you can restrict the size of the input using max length and min length. To apply these rules, Pydantic provides a utility function called field. The traditional way developers applied these constraints was by assigning the field function as the default value of a model attribute. For example, you would declare an age attribute, type hint it as an integer, and set it equal to field, passing in GT equals 0. This structure works, but it introduces friction. If you need a positive integer across 15 different models, you are writing that exact same field assignment 15 times. Worse, because the field function occupies the default value assignment slot on the model, it complicates things when you actually want to assign a real default integer to that attribute. Here is the key insight. You do not have to tie your validation rules to the attribute assignment at all. You can bake them directly into the type definition itself using Python's typing.annotated. Annotated is a standard library feature that lets you attach arbitrary metadata to a base type hint. Pydantic is specifically designed to look inside an annotated type, find any field functions you provided, and extract their validation rules automatically. When you use annotated, you posit two distinct pieces of information. First, you provide the base Python type, like an integer or a string. Second, you provide the metadata, which in our case is the Pydantic field function containing your constraints. Let us build a reusable age type to see how this flows. You define a new variable in your code called positive int. You assign it to annotated. Inside annotated, you pass integer as the base type, followed by a comma, and then the fields function with GT equals 0. You have just created a custom reusable type constraint. Now, whenever you define a user model or an employee model, you simply type hint your age field with positive int. You do not need to call the field function on the model attribute. This approach separates your type definitions from your model structures. Your models stay incredibly clean, reading just like standard Python classes without clutter. If your business logic changes later and you suddenly need an age field to be greater than 18 instead of 0, you update the positive int definition in exactly one place. That updated constraint cascades instantly to every model using it. Furthermore, because annotated is a native Python feature, static type checkers understand perfectly that your custom positive int is ultimately evaluated as a standard integer. By decoupling validation metadata from the default value slot, the annotated pattern transforms field constraints from repetitive boilerplate into shared libraries of strict, reusable domain types. Thanks for spending a few minutes with me. Until next time, take it easy.